Classroom teachers are always looking for tools that build engagement, connect learning to the real world, and develop future-ready skills. One of the most overlooked tools for doing all three is the microcontroller. A microcontroller is a tiny programmable computer designed to sense information, make decisions, and control outputs. These small devices power many things students already use every day, including smart thermostats, fitness trackers, appliances, traffic systems, and toys. In schools, these tools can turn passive learning into active exploration. Instead of only reading about science, data, or engineering, learners can build devices that collect information and respond to the world around them. For educators, this matters because today's students need more than content knowledge. They need problem-solving skills, coding experience, design thinking, collaboration practice, and confidence using technology. Microcontrollers provide all of those opportunities in one project-based package. Popular options include Arduino, Adafruit Circuit Playground, Raspberry Pi, and the BBC microbit. While each has strengths, many find this specific board useful because it was designed for education from the beginning. The microbit is a handheld device that gives students immediate access to coding and physical computing. It includes built-in sensors for temperature, light, and sound. It has a 5x5 LED display, push buttons, basic sound output, and radio communication for sending data to other units. While it lacks built-in Wi-Fi, it can connect through USB to a computer or share data through radio signals with nearby devices. These features mean students can begin creating useful projects almost immediately without needing many extra parts. One of the biggest barriers teachers face with technology is setup complexity. This platform helps solve that problem. Students can code using block-based programming, beginner Python, or Scratch-style interfaces in a browser through Microsoft MakeCode. Once they finish coding, they download the file and drag it onto the drive. The device starts running right away. This quick process reduces frustration and gives learners rapid success, which is especially important when introducing coding for the first time. For elementary teachers, it can be used for simple cause and effect projects. Students can program the lights to show shapes, letters, or emotions. They can create digital dice, reaction timers, or step counters. These activities reinforce sequencing, logic, and perseverance. Students quickly learn that mistakes in coding are not failures. They are clues that help improve the design. At the middle school level, the microbit becomes a strong STEM and inquiry tool. Science classes can use the sensor to compare indoor and outdoor environments. Students might ask whether shade changes air temperature, whether hallways are warmer than classrooms, or whether windows affect room conditions. Math teachers can collect data sets, calculate averages, graph trends, and discuss variability. Social studies or geography teachers can explore how technology gathers data to solve community problems. For high schoolers, the platform can support engineering, computer science, environmental science, and advanced project design. Students can build prototypes, automate systems, gather repeated measurements, and solve authentic problems. They might design a plant monitoring system, create a wearable alert device, or build a hallway traffic counter. The key shift is that students are not just consuming technology, they are creating it. One especially powerful classroom use is environmental data collection. The device can read temperature every few seconds and send the info through USB to a connected computer. That computer can run a script to capture the readings, organize the data, and upload it to mapping systems such as Esri's ArcGIS Online. Once uploaded, students can view their own live data on maps, charts, and dashboards. Imagine students comparing temperatures from multiple classrooms, school entrances, playground areas, or outdoor shade zones. Suddenly, data analysis becomes real because the information came from their own investigation. Another exciting feature is radio communication. Multiple units can send data to one central hub connected to a computer. This allows students to create a simple sensor network across a classroom, school building, or outdoor campus area. Teachers could organize projects on noise levels, temperature changes, sunlight exposure, or movement patterns. Students begin to understand how modern smart systems and Internet of Things devices work in cities, transportation, agriculture, and homes. Teachers often ask whether coding tools fit standards and curriculum goals. The answer is yes. Projects naturally support science practices such as asking questions, planning investigations, analyzing data, and designing solutions. They support math through measurement, graphing, patterns, and statistics. They support computer science through algorithms, debugging, variables, and logic. They support communication skills when students explain their designs and present findings. They also align well with project-based learning and career readiness goals. Another advantage is student motivation. Many students who feel average in traditional classes become highly engaged when asked to build something meaningful. Hands-on tools can reveal talents in creativity, persistence, leadership, troubleshooting, and systems thinking. Students who may not shine on worksheets often thrive when given a challenge and the chance to invent. Teachers do not need to become expert programmers before starting. A simple first lesson might involve displaying a heart on the LED screen when button A is pressed. The next lesson might measure temperature. The next might record data over time. Growth can happen one small step at a time. Students often learn quickly and help one another, creating a collaborative classroom culture. The big message for educators is simple. Microcontrollers make learning visible, active, and meaningful. Among the many options available, the BBC microbit stands out because it is affordable, durable, beginner-friendly, and packed with useful features. If you want students to code, investigate, design, collaborate, and think critically, this small device can create big learning opportunities for data collection, mapping, and much more.